So back to what we are discussing so far. Now, out of the method that we have discussed before, we discussed about how to use factorization method as well. We check how to make use of completing the square method. So another method that we are going to talk about is using quadratic formula. So any of the method that you apply, either you apply factorizations, either you apply complete square method as well as this formula, you are going to get the same result. You just have to choose any one you prefer out of all the method. Now, for example, if I have something like this, so the formula is given as this: x is equal to minus b plus or minus square root of b square minus 4ac over 2a, if you use the completed square method. Now, what you are trying to tell us here is that any value, it might be either y squared or p squared, anything. So any value we have beside our x squared is always for a. Any value we have beside our b, we have beside our x, is going to be our b. Why the one that doesn't have any coefficient is going to be our c? If you are solving any problem, to apply this formula, you can see the formula we have: minus b plus or minus square root of b square minus 4ac over 2a. Meaning, if I'm solving a problem, the first thing I need to consider is to firstly find out the value of my a, the value of my b, as well as the value of my c. So if you look at this problem, for example, I have ax squared. Okay, let's demarcate this example. Let's say we have 3x squared plus 5x plus 6. Let's say in this problem, I want to find out my a, I want to find out my b as well, I want to find out my c. So if you look at this, you can see this is x squared. So I told you here, by comparison, this is going to be our a, this is going to be our b as well, this is going to be our c. So down here I can have a to be 3 here, right? So I can have my b to be 5 as well. You can have our c to be 6. So meaning, in some problem, let's say I have something like x squared plus 5x plus 1, for example. Now I want to evaluate my a, b, and c. So here, this is going to be my a, this is going to be my b and c. So clearly you can see that in that x squared, there is no number beside it, meaning the number that we have beside them is 1. So that means here, my a is going to be 1, my b here is going to be 5 as well, my c is going to be 1. So those are the way of how. Now, in some problem, you may have y instead of having x. You can see here we have x. It can be maybe y or p or q or whatever. Or let's say we have something like 2m squared plus 5m plus 20 equals 0. You can see here, instead of using x, they decided to use m here. It's still the same thing. Either they use m, either they use any other alphabet. So here, I can evaluate my a, we can evaluate our b as well, we can evaluate our c. So from here now, you can see the one we have beside m squared is 2, right? So that means our a is equal to 2 as well, our b is equal to 5, and at the same time our c is equal to 20. So that's how we'll be evaluating the values one after the other. So let's see some problem. So in general, that means here you have to solve the formulas, that is quadratic formulas, using the complete square method, which is x is equal to minus b plus or minus square root of b square minus 4ac over 2. You can see we use x here. As I told you, you can use m. If they use m, that means instead of writing x here, I will replace this x with m. That's going to be m is equal to, it depends on anything they use. Either they use y, either they use x, either they use w, whatsoever they use. Just make sure that you evaluate your a, we evaluate our b, and at the same time our c. So let's solve some problem. Let's say we have the set solve using quadratic formula. Solve using quadratic formula. Using quadratic formula. 1. Say we have x squared plus 5x plus 6 equal to 0. So the second one, let's say we have 2x squared minus 5x plus 3 equal to 0. So let's see how we can approach these two problems using quadratic formula. So in the first problem, what I have there is we have x squared plus 5x plus 6 equal to 0. The first thing I will need to do is to find out the value of my A, the value of my B, at the same time the value of C. Now, by comparison with this, so now we can see there's no question. That means the equation that we have beside x squared here is what? Yeah, it's 1 because the two number between them, that's 1. So here that means A is equal to 1 here, then B is equal to 5, and C is equal to 6. It doesn't matter with the arrangement. That's another thing you have to take note on. You might try to arrange it in other way around, in which we can have, instead of writing this for this question like this, they can write it as 6 plus let's say x squared plus 5x. Just target your x squared. Any numbers that you have beside your x squared is your A. So here now, if I want to find, don't say this is my A. No, this one is wrong, because you can see this is the number without the coefficient. Now I can go back here. This is going to be my A, this is going to be my B, and this is going to be my C. The arrangement does not matter. What matters most here is how you can evaluate or pick out the value of your A, the value of our B, at the same time the value of our C. So now, going back to this problem, we have already got out the value of A, B, and C. So clearly, our A is equal to 1 here, our B is equal to 5 as well, our C is equal to 6. So the next thing now is to apply the quadratic formula, which says that x is equal to minus b plus or minus square root over b squared minus 4ac all over 2a. Now, let's substitute the values one after the other. I can have x is equal to minus, what do we have for b here? You can see our b is 5, isn't it? Yeah, so our b is 5. We have minus 5 plus or minus square root of our b again is 5. I can have this one to be 5 squared minus 4. Now, from the data we got here, our A is 1. We have 1, and our C is 6, all divided by 2. At the same time, our A again, we have it as 1. We have 1 here. I hope you are following, right? So now the next thing is to continue this. I can have this one to be x is equal to minus 5 plus or minus, 5 square in mathematics. So, people used to get this one logic. It's not 5 square, it's not 5 times 2. Meaning, if I have 5 square, it simply means 5 times 5. It's not 5 plus 5. So please take note of that. So 5 times 5 of this, you are going to have it as 25. So here I can have square root of 5 square now. And we have 25 minus. Now, the sign that join all these three numbers together is a multiplication, because what I have here is bracket. So that means I can say 4 times 1. So 4 times 1, and we have 4. Then 4 times 6, of course, we are going to have 24. Then all divided by 2 times 1, we can have this one to be 2. Now, at the same time, you can go further by saying x here is going to be equal to minus 5 plus or minus square root of 25 minus 24. Of course, we are going to have 1, all divided by 2. So the next thing now, every number have its own root. So I can find the square root of this one. What's the square root of 1? Yeah, if you multiply 1 times 1, of course, you are still going to get 1. That means the square root of 1 is 1 here. So we can have this one to be x is equal to minus 5 plus or minus square root of 1 is 1 all over 2. So meaning this simply means this number can be plus 1 or it can be minus 1 because of this sign. We have a sign there. It can be plus 1 or it can be minus 1. So meaning if I want to express this, I can go further by saying x is equal to minus 5 plus 1 all over 2. Or, so now, the meaning I'm taking it when it is positive. That's a plus 1. So I want to take it when it's negative now. I can have it as minus 5 minus 1 over 2. You can see it doesn't affect the first number because the sign is only meant for 1, either plus or minus 1. So meaning I can have x is equal to minus 5 plus 1, and we have minus 4 over 2, or minus 5 minus 1. Of course, you are going to have minus 6 over 2. So here I can have x is equal to minus 2 in 4, I will definitely have 2, or x is equal to 2 in 6, I will have minus 3. So that means here our x is equal to minus 2, and as well our x is equal to minus 3. So either you apply factorizations, or you apply completing square method, or you apply this quadratic formula. You can see that you are going to get the same result. So let's take a look at the second problem. The second problem we have second problem, they say we have the second problem, they say we have 2x squared minus 5x plus 3 is equal to 0. The first thing I will do is to find out the value of my a, to find out the value of my b, and to find out the value of my c. So using this approach, now you can see this is my a here. You can see the point of a here, x squared here is not 1. So this is my a, this is my b, as well as this is our c. That means our a here is 2, b is minus 5 as well. Our c is 3. So after evaluating the value of a, b, c, then we can make use of the formula, which says that x is equal to minus b plus or minus square root of b squared minus 4ac all over 2a. Please note, as I told you earlier, it depends on the alphabet being used. You can see here they use x. They can use y. They can use that means they are using w now. So that instead of saying x here, can you get what they are going to have here? Yes, exactly. It's going to be w. That means instead of having the answer to be x is equal to this and that, it's going to be w is equal to the first one or w is equal to second one, even if you have repeated root. Now, you can go further now. We have, let's substitute the value of our ABC here. If I substitute, that means here I can have, let's write it here. I have x is equal to, now my a is, my b is minus 5. You can see in the formula we have minus initially. As well, the b that we have also contain minus. So it doesn't matter, just go for that. Minus, b is minus 5. We have minus 5 plus or minus square root of our b again is minus 5. That's minus 5 all square minus 4. Our a is 2 and our c is 3. Then all divided by 2 bracket over 2 because our a is 2 here. So I have this one to be x is equal to minus minus. If you could recall, if you watch our previous video, we talk about how to make use of all those signs. That if I have minus multiplied by minus, yeah, that's going to be plus. Then plus multiplied by plus, that's going to be plus as well. If you have plus times minus, or we have minus times plus, that's going to be minus. So now you can see here, what I have here is minus, and as well what I have here is minus. So minus times minus, of course, we are going to have a plus. So we have 5 here, plus or minus square root of. Now, don't be confused about this one. You see, when I have minus 5 square, it doesn't mean that you are going to evaluate the value of minus and only square the value of 5. The minus will go along together with that numbers. That means if I have minus 5 square, meaning minus 5 times minus 5. At that moment, then if I multiply minus by minus, of course, we have a positive. So minus 5 square here, we have 25. I told you earlier, what join these three numbers together is multiplication. So 4 times 2, we are going to have 8. 8 times 3, we are going to have 24. Then all divided by 2 times 2, we are going to have 4. Then here we are going to have x is equal to plus 5 plus or minus square root of 25 minus 24. Of course, you are going to have 1 as well, all divided by 4. So here you can have this one to be x is equal to plus 5 plus or minus. We are lucky here that we still have the same number here. Square root of 1, we are going to, it can be any numbers. Even if it be a number that we have a point, if you press the square root of that numbers, if it only have a negative, that's another case. That one will also complex, and we are coming to that. So now, here now, if you have a number like this, square root of 1, of course, we are going to have 1, then all divided by 4. So here we can have this one to be x is equal to plus 5. This means it can be positive or it can be negative. That is a plus 5 plus 1 over 4, or x is equal to plus 5 minus 1 over 4. So meaning I can have this one to be x is equal to 5 plus 1. That's going to be 6 over 4, or 5 minus 1, we are going to have 4 over 4. Then here I can have, you can see these fractions, if you like, depending on the result you have in the problem you are solving. This one you can leave the answer in form of fractions, or you can leave in form of a decimal, right? Because if you look at these numbers, if I said what two number can go in 6 and 4 without remainder, that's 2. So if I divide the 2 in 6, we have 3. or 2 in 4 and we have 2. So here 4 in 4 and we have 1. Let's say you are solving the problem and you discover that the fraction is not there. They give you the answer in form of decimal. You can just define this one. So 3 divided by 2, that's going to be 1.5, or x is equal to 1. Either you leave it at the first one or the second one. It's still the same, depending on how they leave the result there. So you can see now in some problems, don't be confused. We may have a number that doesn't have a perfect square root here. Maybe the number gives you a point. You can go further, maybe approximate the number to either 2 decimal place or 3 decimal place. Then follow the same process. The only way we can have a problem is when the number that we have inside the root doesn't have maybe contain a negative. Because you know, if you can check, if you press square root of minus 5, for example, you can see this one will not give you an accurate result. It will show you, especially if you are using either Casio or combo calculator, you see it's showing you syntax error. No. Mathematics is just the study of counting. If you have a square root of minus 5, it has a solution. We can be able to evaluate that using the knowledge of a complex number. Let me just use like 2 minutes to explain this. Let's say I'm solving a problem and I have something like this inside my bracket. Let's say we have something like this, so that we can take that one as well. Let's say I have square root of minus 5, for example. You see, if I press square root of minus 5, definitely that one will give me a negative. It will be showing me syntax error if you use your calculator. But there's something like math error here. We can make use of complex. In complex number, if I have square root of minus 1, it's called high. So here now I can write this, or j in some cases. We will write this one as square root of minus 1 times 5. By splitting these two numbers, it's like if I have square root of AB, we can rewrite it as square root of A multiplied by square root of B. Then I can just break this one down as square root of minus 1 times square root of minus I times so times this. So from here, I can have this one, that's square root of minus 1 times 5. You can see if I multiply 5 by minus 1, of course, I will have minus 5. So as I told you earlier, if you have square root of minus high, in some cases they use j or something like I here, I can write this one as I times then you can evaluate your results. So please take note of this. If you are using quadratic formula, let's say inside the bracket, let's say we have a negative result. Just even idle numbers, let's say I have square root of minus 200, for example. Follow the same process. This is nothing but square root of minus 1 times 200, then split it into 2. I have minus 1 times square root of 200. Then you know this, then find the value of this, then you go back to your problem. So that's all about how we can make use of quadratic formula. So let's see how can we solve a problem related to sum and product using alpha and beta equation, because I know that one is very important. So let's see how we can make use of that. They derive that one using this quadratic formula. We can play with alpha and beta equations. Alpha and beta. Let's say, for example, you know, from here we have x is equal to minus b plus or minus square root of b square minus 4ac over 2a. Now, let's represent the alpha to be when it is positive, and let the beta to be when it is negative. That you can say let alpha to be the first one, which is positive here. Minus b plus square root of b square minus 4ac over 2a. So when it is negative as well, beta is equal to minus b plus or minus square root of when it is minus, sorry about that, b square minus 4ac over 2a. So I want to find the sum here as well. I want to find the product. So now, sum, you know, when it says sum, what does that mean here? It means to add. Now, let's say I want to find the sum. I want to find the alpha plus beta. So the sum we have here is the alpha that we have here, what we have here is minus b, you can see from here, plus square root of b square minus 4ac over 2a. So now plus, what is a negative? The other beta that we have is minus b minus square root of b square minus 4ac all over 2a. So by taking the LCM of this one, you can see what we have here is 2a. At the same time, what we have here also is also 2a. Now, LCM of 2a and 2a, of course, we are going to have 2a. 2a and 2a, that was going to be 1. Then times 6, I can have minus b plus or minus square root of b square minus 4ac. You can see this is positive and negative. Okay, don't worry. Let's go about that. 2a in 2a, that's going to be 1. I can have this one to be minus b minus square root of b square minus 4ac. Now, remember how we normally play with our sign. If I have plus times minus, that one is minus, that plus times minus is minus, minus times minus, that one is plus. So now, if I multiply all this one by positive, of course, it's going to remain as a minus, because plus times minus is minus. At the same time, plus times minus here is also going to be minus. So that means here I can have this one to be minus b plus or minus plus, sorry about that, going to be square root of b square minus 4ac minus b minus square root of 4ac over 2a. So with this, let's firstly finish this one before we derive the other one first. Now, because I need to derive the alpha plus beta, which is the sum, at the same time, which is the product. So now, by evaluating this, that means here I can have this one to be minus b. Of course, that one is going to give me minus 2b plus and minus of this one. You can see this is positive, this is negative. That's going to be 0 over 2a. So 2 can cancel 2 here. Then I can have alpha plus beta to be minus b over a. So which means anytime I need to find my alpha plus beta, I can make use of minus b. We have already talked about how to find the a, how to find the b, at the same time how to find the c. Now let's take a look at, this is the sum. So let's take it when it is a product, multiplication. The same method, the same process. Let's put it here. So I let my alpha to be minus b plus square root of b square minus 4ac over 2a, and I let my beta to be minus b minus square root of b square minus 4ac over 2a. Now let's multiply them now to find the product alpha beta. So the first one multiply the second one. The first one we have here is minus b plus square root of b square minus 4ac over 2a. Then the second one we have is minus b minus square root of b square minus 4ac over 2a. So now let's expand. If I expand this, meaning the first one we have here, we multiply these two. At the same time, the second one we have, we also multiply these two now. So minus b times minus, you can see this has minus, and at the same time, this one also have minus. So minus times minus is going to be what? Yes, exactly. It's going to be plus. So b times b, and we have b squared minus times minus here, and we have plus b multiplied by square root of b squared minus 4ac. Of course, we can have that one to be b square root of b squared minus 4. You can see it doesn't affect the one we have in the root because b doesn't have the root here. Now, let's go for the second one now. Plus times minus, and we have minus square root of b squared minus 4ac multiplied by square root of b squared minus 4ac. You can see I've already go for the first one, minus b times minus b. I have b squared because minus times minus will be plus. Minus times minus here, we have plus b times square root of this. I have b square root of b squared minus 4ac. Now the second one now, plus square root of b squared minus 4ac multiplied by b. Of course, you are going to have b square root of b squared minus 4ac. Now plus times minus, that's going to be minus. Now square root of b squared minus 4ac multiplying by square root of b squared minus 4ac. There's one thing you have to take note here in underscore. That one is so from if I have root of 2 times root of 2, you'll be taking this is supposed to be root of 4. Yes. And square root of 4 is going to be 2. But you don't need to waste your time. So far, if the number we have in the root are the same, you can just pick one. Let's say I have root of 2 times root of 2. I can just say 2. Root of a times root of a. This is the same thing as just a. Root of x plus 1 multiplied by root of x plus 1. Of course, this one is just x plus 1. So meaning, if I want to apply the same logic here now, I have root of b squared minus 4ac multiplied by root of b squared minus 4ac. That means that one can just be b squared minus 4ac. You can see I bracket because we have a minus sign outside here, right? So all divided by 2a multiplied by 2a, 2 times 2, that's going to be 4. a times a, that's going to be x squared. Now I can have alpha beta equal to b squared plus b root of b squared minus 4ac minus b root of b squared minus 4ac. That's going to be 0 because this is positive, this is negative. So then open the bracket of this, minus times b squared, I can have minus b squared, minus times minus, I can have plus 4 because minus times minus is plus, all divided by 4a squared. So meaning b squared minus b squared, of course, that's going to be 0. So what we have left is now is 4ac over 4a squared. You can see 4 and 4 here. 4 can cancel 4 here. This is a. You know, if I have a squared, it simply means a. Now, a can cancel a here. So that means what we have left is c over a. So meaning, if I want to find the value of the alpha beta, we normally use c over. This one is the most important thing. How to make use of alpha. You can use this sum and product, which is alpha plus beta and alpha beta, to derive many other formulas, either alpha cube plus beta cube, either alpha square plus beta square, or either alpha cube minus beta cube. So now that means if I'm looking for the alpha beta now, what I'll be using is c over what? C over a. So you have derived the other one. The other one we derive is alpha plus beta. So we have that one to be minus b over a. So we'll be make use of these two, but now we can approach a problem how we can make use of these two. So now let's take a look at some examples on how we can find alpha plus beta, alpha beta, or any other root.